In the last lecture, we talked about what problem DevOps is trying to solve, and this will go a little bit deeper into sort of what are the pieces of DevOps and what are some of the processes. So again, just to review the definition, it's a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production. Quality is important when you do this. So if you look at DevOps, there are three different high-level kinds of aspects to it. There's the technical aspect, which is mostly what we focus on in the course. There's the organizational aspect and the cultural aspect. We'll go a little bit deeper into the organizational aspect in the next lecture. The technical aspect, you can talk about tools, you can talk about processes, and you can talk about architecture, and we will end up talking about all of those. So the processes themselves can be divided into 5 categories. One is to treat operators as first-class citizens. The second is to make the development team more responsible for incident handling. The third one is to enforce deployment practices uniformly across both development and operations. Use continuous deployment. We'll talk a lot about that. And develop infrastructure code using the same processes as application code. So if we go down and into each category, the over-the-wall model is that the developers don't necessarily get requirements from operators. They don't have their code generate good logs or error messages, and this causes operators to spend a long time troubleshooting problems. So if you treat operators as a stakeholder and gather their requirements, then you do a better job of satisfying it. I mean, in theory, software engineers always look to all their stakeholders, but frequently operators are not considered the same category as, say, a customer. You can also make the developers more responsible for incident handling. So the traditional incident handling sequence is the operator is informed of a problem. The operator makes a decision as to whether this is an operational problem, in which case it's their responsibility, or a bug, in which case it's the developer's responsibility. And if it's a developer's responsibility, the incident is escalated to the developers. There's a whole process for this. The problem is that time has gone by and the developers have lost the context for potential solutions. So you write the code, you check it in, it's 2 months later, you get a bug report. The second problem is that developers don't necessarily see the problems they cause directly, and they may be insensitive to how frequently these problems are caused. And so making the developer's first point of contact for incident handling is one attempt to solve this problem. It's not universally done, but it is done in, again, we'll talk about roles and responsibilities in the next lecture, and part of the reading for that is a video of a Google reliability engineer. So the third one is to enforce deployment practices uniformly across both development and operators. Operators who develop infrastructure code have traditionally not used the same deployment practices as developers. For example, they may log in as a super user to apply security patches, and without going through version control, automated testing, and so on, their scripts may or may not be version controlled. And so the goal is to have every executing image traceable in terms of its constituent parts and its version history, and we'll get into that again. Continuous deployment is a process and related practices that allow developers to place their code into production without human intervention. This is very definitely a tool process architecture kind of practice, and we will talk about this in great detail. And finally, develop infrastructure code. Infrastructure code means the collection of scripts that the operators develop to do various things. And do this using the software engineering processes that developers have been trained to do. So, for example, test-driven development, automated tests, version control, pair programming. And operators historically have not used these processes. And so the goal of this set of processes is to reduce the error rate for infrastructure code. The DevOps processes are not exclusively in operations. So during requirements, you get requirements from operators. During development, part of the processes are to have small teams, limited coordination, various types of unit tests. In the build, it should be totally automated. In test, it should be totally automated. Deployment, you use deployment tools and automate that as well. And there's when it goes into production, there's monitoring and live testing, and we'll get into that again. But the point is that the DevOps processes and DevOps permeates the life cycle of a system. So as an example of an organization that uses DevOps, it's IMVU, is a social media company. They deploy new code somewhere in the order of 50 times a day. The essence is in their test suite. They have they have around 1,000 test files, which are distributed across 40 machines, and it takes about 9 minutes to run a test suite. And then, so you commit, you run your test suite. 9 minutes later, you have an initial deployment to a small subset of production machines. And this is called canary testing, and we'll talk about that as well. So, and then a sampling program will go out and check and see if the results are correct. If there is a statistically significant problem, then it's automatically rolled back. Otherwise, it's pushed to all the production machines. In general, quality is important. Okay, so quality includes the functionality for all the stakeholders and various types of abilities for the system being developed as well as the pipeline. So availability, performance for the system being developed, there's a whole bunch of them. And if you're not worried about quality, then deploying quickly is not difficult. You just put it out. It just doesn't work. And so quality ensures that the system being deployed is useful. And the quality of the delivery mechanism is also important. So failures in the delivery mechanism adds time to the deployment. So the quality of the delivery mechanism includes repeatability, availability, performance of the delivery mechanism, and traceability. And there are 4 times implied in the definition. There's the time before the code is committed. There's the time between the commit and the deployment. There's a time in which it's initially put into production. This is probationary. And so you would, if you just put something new out, you would monitor it more closely. And then there's normal production. This is after you've gained some confidence that its quality is at least equal to other portions of the production system. Okay, so activities during requirement gathering and during the design will affect the quality. We'll talk about some of that. Activities after deployment will affect quality. We'll talk about some of that as well. So to summarize, DevOps in general is motivated by a desire to reduce the time to market for changes to the system. And the definition is that it's a collection of processes whose goal is to reduce the time between committing code and normal production. Quality is important. 4 time intervals are important. Pre-commit, between commit and deployment, probationary production, and normal production.